In this video, we'll take a quick look at differential equations and very simple differential equations that you might see in a Calc 1 or in an AP Calculus class. So first off, what is a differential equation? Well, it is basically an equation that relates variables with their derivatives. And in order to solve them, we're going to do four things. So solve. The first thing we're going to do is separate variables. And that's going to mean to get all of the y's and dy's on one side, the x's and dx's on the other side, or whatever variables are in the problem. After we separate the variables, we're going to end up taking an antiderivative. So that's going to get rid of the derivatives and get us back to our variables. The third thing, we're going to use the initial condition, which is going to be some given information, to solve for the constant of integration. And the last thing, we need to make sure that we write our answer. Sometimes this is very simple, sometimes this involves a lot of work. And there are many things that can go wrong here. I'll try to identify those. But these are the steps that we will end up taking. So here are a couple examples. The first thing I'm going to do is separate these variables. So I'll have all the y's and dy's on the left, and I'll multiply both sides by dx, so I have 6x squared dx. Now, to get rid of these d's, I'm going to take the antiderivative of both sides. The antiderivative of dy is y. The antiderivative of 6x squared is 2x cubed. But since I'm taking indefinite integrals, I would usually have a plus c here and a plus c there. I'm not going to have both of these plus c's because I could just subtract this arbitrary constant from this side, and one arbitrary constant minus another arbitrary constant is just going to be a third arbitrary constant. So I just put this plus c here that covers both of them. And I'm not going to show that step in the next two examples. Okay, now I have my constant of integration. I'm going to use this initial condition to find out what that c is. So 5 equals 2 times 2 cubed plus c. 2 cubed is 8, times 2 is 16. Subtract 16 from both sides. And now I need to write my answer. So y equals 2x cubed minus 11. And this is the function whose derivative is 6x squared and also goes through 2, 5. So that's a very simple case. Let's see two more that are a little bit escalating in difficulty. So here's one. Find the particular solution to this with initial condition r of 1 equals negative 2. And I'll start off the same way by separating the variables. In this case, I'm going to have to multiply both sides by r cubed, and so on the left I'll have r cubed dr, and multiply both sides by d theta, so that's going to equal theta squared d theta. Next thing I will do is take the antiderivative of both sides. The antiderivative of r cubed is r to the fourth over 4. The antiderivative of theta squared is theta cubed over 3. And notice I'm going to put the plus c once here. I will substitute in my initial condition, replacing the r with negative 2. And the theta with 1. Negative 2 to the fourth is 16. Divided by 4 is 4. 1 cubed is 1, divided by 3 is 1/3. Subtract 1/3 from both sides, which will give me 11/3 equals C. And now I actually have a little bit more work to do, so let me bring this over here, replace the C, and I'm sitting at r to the 4th over 4 equals theta cubed over 3 plus 11 over 3. And I guess I can write this as one fraction, so I have r to the 4th over 4 equals theta cubed plus 11 all over 3. I want to get r by itself. The first thing I can do is multiply both sides by 4, and that gives me r to the 4th equals, and it's going to distribute into the numerator, 4 theta cubed plus 44 over 3. And now to get rid of the 4th, I need to take the 4th root. But since this is an even power, I'm going to end up with a plus or minus 4th root of 4 theta cubed plus 44 all over 3. One last problem here. Plus or minus here makes this not a function. My particular solution will be a function. And how I deal with that is the following. I look back at this initial condition. When I put 1 in here, I get 1 cubed times 4 plus 44 gives me 48, divided by 3 gives me 16. The 4th root of 16 is 2. I want to have my output be a negative 2, so I will choose the negative sign here. So r will equal negative 4th root of 4 theta cubed plus 44 all over 3. One last example, and this example is similar to an AP problem that showed up on the 2014 free response for the AB, and I think the BC test as well. I'm going to start off the same way. I'm going to divide both sides by 5 minus v and multiply by dt. So I get dv over 5 minus v equals cosine of t dt. Next thing I'm going to do is the antiderivative. And this antiderivative is really a lot like the antiderivative of 1 over v, which would be the natural log. So I'm going to have from this the natural log of the absolute value of 5 minus v. This happens when the denominator is linear. If this were a squared, I'd have a very different antiderivative. But if this is linear, it's going to be that. I need to have a negative sign here to account for chain rule because this v is negative. And that's going to end up equaling the antiderivative of cosine is sine. At this point, I'm going to use my initial condition. So I'll put in 0 for t, 1 for v. So I have negative natural log of the absolute value of 5 minus 1 equals sine of 0 plus c. Sine of 0 is, of course, 0. 5 minus 1 is 4. Absolute value of 4 is 4. So I'll get the negative natural log of 4 is equal to c. Now I plug this back in here. So I have, let me actually bring it up so I got some more room. I'll have the negative natural log of the absolute value of 5 minus v is equal to sine of t minus the natural log of 4. I need to get rid of this negative sign, so I'll divide everything by negative 1, and I'll get the natural log of the absolute value of 5 minus v equals negative sine of t plus the natural log of 4. To get rid of the natural log, I'll use it as a power of e, so I'll have 5 minus v equals e to the negative sine of t plus the natural log of 4. But recall that, let me change colors, if I have the sum of an exponent, this is really e to the negative sine of t times e to the natural log of 4, because the product of exponentials is going to have the sum in the exponents. And e to the natural log of 4 is just 4. So I will get 4 e to the negative sine t. I still have absolute value of 5 minus v. Next thing to get rid of is the the absolute value. If the absolute value is equal to this, then 5 minus v is equal to plus or minus 4 e to the negative sine t. Now I'm going to subtract 4 from both sides, and I will get negative v equals, subtract 5 from both sides, equals negative 5 plus or minus e to the negative sine t. Now I'm going to divide everything by negative 1 to get rid of this negative sign. I'll have v equals positive 5. Plus or minus divided by negative is just a minus or a plus. It's the same thing. So plus or minus e to the negative sine t. But like before, I need to figure out which one to use. Now before, let me flip back to this problem, this was negative, so this was negative. But that's not always the case. That's not the way I explained that one. Same thing happens here. When I put in 0, I want my output to be a positive 1. Sorry, this should have 4s. When I put 0 in here, e to the 0 is 1. 4 times 1 is 4. 5 minus 4 gets me this positive 1. 5 plus 4 would give me 9. So I need to take the minus even though this is a positive 1. So v equals 5 minus 4 e to the negative sine of t. I hope this helped out. This was just a little example of some of the things that can happen. If you have more questions or want to see more examples or different examples, feel free to comment below.